Hi, I am Erika Villadar, and this day we are going to tackle the section 2 of Module 5 Geometric Design, which is Symmetry. What is symmetry? Symmetry, everybody language, refers to the sense of harmonious and beautiful proportion and balanced configuration. In mathematics, symmetry has a more precise definition and is usually used to refer to an object that is invariant under some transformations, including translational, reflection or flip, rotation, or glide reflection symmetry. Although these two meanings of symmetry can sometimes be told apart, they are intricately related and hence are discussed together in this article. Symmetry can be viewed when you flip, rotate, or slide a shape. The quality of being made up of exactly similar parts facing each other or around an axis. Line symmetry. Line symmetry is an imaginary line or axis which passes through the center of a body or an object. If you fold the body along this axis, you will get two or more similar figures. This axis is known as the axis of symmetry. And here are some examples of symmetry. Symmetry has four types, namely reflection symmetry, rotational symmetry, translational symmetry, and glide reflection symmetry. But first, we are going to explain the reflection symmetry. So reflection symmetry is one half of an object or shape reflects the other half. It is also called mirror or line symmetry. One of these examples are the following: human face and the wings of a butterfly. The first picture shows the human face. Why human face in general? Human face are identical on the left and right side. Let's look at just a face. Consider the photo of a woman looking straight ahead. The photo has been cut vertically to separate the face into two halves as shown. And that's the example of reflection symmetry. The second picture shows the wings of a butterfly. Wings of a butterfly have a single line of symmetry down the middle of their wings, are the same on both sides, and this makes them fascinating examples to explore symmetry and have a bit of fun at the same time. Figure 5.5, horizontal and vertical reflection on a square. Consider the square ABCD shown. What symmetries does this figure have? Definitely, there is no translation as there is only one figure. First, note that the figure is preserved if you flip it along the line or line 1 as shown. Vertices B and C will simply switch, so with A and D, but the square will still retain its shape. In the same manner, flipping through line 1 switches D and C as well as A and B. Figure 5.6, slant reflection on a square. Note that aside from line 1 and line 2, there are two lines of symmetry that can be observed. Line 3, diagonal through A and C, which switches the vertices D and B while keeping vertices A and C fixed. And line 4, diagonal through B and D, which switches A and C and keeps B and D fixed. The second type of symmetry is rotational symmetry. Rotational symmetry occurs when a shape or pattern looks exactly the same after being rotated by some degree about a point. It is also known as radial symmetry. And the first example is starfish, and the second one is flower. Starfish body radiates out from a central point because, like an object, when it's rotated in its axis, the shape still looks the same. And that's what we call rotational symmetry, as well as the flower. Figure 5.7, a 90-degree rotation on a square. Now, locate the center of the square, say at a point P. Rotate the square at the same point through some amount of rotation. If the rotation is done at 90 degree counterclockwise, then point A moves to point B moves to point C, and point C moves to point D, and point D moves to point A. The shape of the square, however, remains unchanged. Similarly, a 180-degree rotation moves A to C, B to D, C to A, and D to B. These symmetries are called rotational symmetries. Figure 5.8, rotation on a single side. Thus, the square has 8 symmetries, 4 reflection, and 4 rotation. Interestingly, it is Leonardo da Vinci, renowned in the field of visual arts, who is credited for the discovery that there are only 2 classes of symmetries of finite design: those that contain only rotation and those that contain both rotation and reflection. The square contains both rotation and reflection, but the picture shown contains only rotational symmetry. The third type of symmetry is translation symmetry. A shape or image is moved from one position to another, a specific distance in a specific direction with the same orientation. Example, a note and a plant. Figure 5.9, border design created using translation of a triangle. The next design are one-directional design, also called border design or frieze patterns. This design involves translation but only in one direction, that is usually horizontal. The figure below illustrates a simple border design using a right triangle as basic design. The last type of symmetry is a glide reflection symmetry. Glide reflection symmetry, it is the combination of reflection and translation symmetry. It is much like translational symmetry. An example of this is a leaf and a footprints. For further discussion regarding this topic, you may visit the YouTube channel of Leomar Ibanez for the part 2.